Hi, for today we're going to explain this idea of dividing polynomials over monomials. So in a sense, it's something very simple. It's very close to something that we have actually been doing in the previous weeks. And that is the fact of simplifying fractions such as this one. I'm going to call this example 0, just for the sake of setting a precedence and just an introduction to explain this case. So in a sense, what we got to do here is we got to simplify each term by separately. So we got to start with the numbers. We can take 12, dividing this by 12 of the both of numbers. So by doing so, well, 60 over 12 will be 5, and 72 over 12 that make 6. And so that will say, okay, so we got 5 over 6, that's the simplifications of the numbers. And now we got to proceed with the letters. And each letter we got to simplify separately. Will be the C. We subtract the exponent because these two guys are dividing. So it will be 5 minus 1. There will be times. And then we proceed with the D. And D, we subtract the exponent. So it will be D raised to the 3 minus 8. And well, this is pretty simple. So far as what we have been doing previously. The C to the 4th times D raised to the negative 5. Now this negative 5 is not good enough just to leave it like this because we must leave all exponents as a positive number. So at the end we've got this to be written 5 times C to the 4th over 6 raised to the D raised to the 5th. And so far that's pretty much what we've been doing previously. Now the thing we're going to start doing for this topic is that we're going to expand this idea of simplifying monomials over monomials, but now for larger cases. I'm going to start with this one. It will be 24 x to the 5th will be plus 12 times x to the 4th minus 8 times, like the minus, will be 8 times x to the 3rd. It will be all over 6 times x squared. So in a sense, what we got to do is that we're going to simplify the dividing each term. We're going to divide each of the number of the terms we got on the numerator, which is the above part. We're going to divide each of them over the denominator. So I'm going to start with the first one, would be 24 x to the 5th. Here, 24 x to the 5th would be over 6 times x squared. Now, the thing is, this was a simple case, just the beginning, but we should every case ask ourselves, well, would this fraction would be positive or negative? In this case, there is no sign at the beginning, but of course this is a positive term, and so is the one dividing. So this fraction, the first fraction, will be, of course, positive. Now with the next guy, we got to divide this 12 x to the 4th over 6 times x squared. So both of them are positive, so it will be a plus. And then will come the fraction will be 12 times x to the 4th over 6 times x squared. Now we got to do the same with the last two, which we got to divide these guys, and of course this is a negative guy, and there's a positive, will be negative over positive, that make a negative. This is negative, then we come 8 times x to the 3rd over 6 times x squared. And now we got to start simplifying as well. So the 24 6, they got 6 1, and then comes 6 4th, so 4, and then comes 6. I'm sorry, going to continue with the previous. I'm sorry, going to go to here. It will be 6 and 6 will be 6 2, 6 1, and here we can take the 6 out of this one, but we can half and half 3, half 4, and now let's continue on the right. It will be the first guy we simplify to 4 times x, and we got to subtract the exponent, will be 5 minus 2. 5 minus 2, that will make, of course, a 3. Here it is. Now the next guy is going to be 2 times x raised to the 4 minus 2 by subtracting the both exponents. So this will make, of course, a squared. Then comes the last one, the minus. Here we got the 4 and the 3 that came out simplified. Will be 4 over 3. And then the x's will be x raised to the 3 minus 2. 3 minus 2. And of course, this will make 1 power, but we don't write the 1. So it will be just like that. Just like that. And this will be the solution for this first example. Now, I'm going just to explain another couple more just to make this as clear as possible. The example number 2, and that would make something slightly larger. It would be 49 times x to the 6 times y to the 5th minus 9 times x to the 3rd times y to the 3rd plus 28 times x to the 4th. It will be all divided over negative 7x squared y to the 4th. So we got to pretty much do something really close to what we did previously. We just got to be careful. But this first guy, we got to divide it over the denominator. So will be this is a positive over a negative, so this will turn to be a negative fraction. And I'm going to write it will be 49 x to the 6 y to the 5th over 7 times x squared y to the 4th. And then will come the next guy. Will be we got a negative over a negative, so that will make at the end a positive. Make a positive, like if you're positive, it's a positive. So that would be then 9 times x to the 3rd y to the 3rd over 7 times x squared y to the 4th. And now we proceed with the last guy. Will be a positive or a negative over a negative. That will make, of course, a negative. So it will be minus, will be 28 times x to the 4th over 7 times x squared y to the 4th. There it is. So this would be equal to the first fraction. We got to simplify it. It's going to be, of course, 7th 1, 7th 7. And will come the x's. I'm going to write the 7 on the right side. 7. Now the x's will be x to the 6. Will be, we have to subtract the exponents. Will be x to the 6 minus 2. Will make, of course, a 4th. Then will come the next term. It's going to be with the y. The y raised to the 5th minus 4. That will make, of course, a 1th power. A 1th power. Just we don't write the 1, so it's only the y here. Y. And then we go to the next. Be here plus. The 9, the 7 can be simplified, and so let's write this way. It will be 9 7, and the x will be x to the 3rd over x squared. We subtract the exponent, 3 minus 2. Of course, that will make a 1. We just leave the x, and that will be y. And we subtract will be 3 minus 4. That will make, of course, a negative 1. So we will have to rewrite this in a moment. I'm going to do it in another step. And then we got this minus, and of course we can simplify the 28 and 7. That will make a 7 1, 7 4. So we get here minus 4, and then the x's will be 4 minus 2. Subtracting these two exponents, and that will make a 2. And we got this y to the 4th, and there's no y on the numerator, so there's nothing to simplify there. So we just got to write directly and leave the y below just like it is, y to the 4th. There it is, because there's no y to simplify above. Now this we can simplify something because this guy y raised to the negative 1 is not good enough. We must write everything in terms of positive exponents. So I'm going to do that quickly here in the next step. So this would be 9 times x over 7 times y. Then we go minus 4 times x squared over y to the fourth. That will be it for this, actually for this second example, well, technically the third one, right? So, but well, I'm just going to explain one more kind of quickly. Example number 3. And this guy is going to be, this one will be 27 x squared y to the fifth times c, it's a c, make it bigger, minus 18 times x squared y to the fourth times c to the fourth, and we close the bracket, will be divided by 6 times x times y to the fourth times c squared. There it is. But this is just another way you can just find out, just get these kind of exercises, which is pretty much the same as the fraction. I'm just not the biggest fan of using this symbol, so I'm just going to start right away to transform into a fraction, because I think it works nicer in many ways. And this will be 18 times x squared y to the fourth c to the fourth over the 6 times x times y to the fourth times c squared. So now we proceed to do what we did with the previous cases. I'm going to continue here on the left just to save space. So the first fraction will be 27 x to the fourth y to the fifth times z over 6 times x y to the fourth times c squared. This is a positive fraction because both of the guys are positive. Now with the second guy, it's going to be negative over positive, so I will make it negative. Here comes 18 times x squared y to the fourth times c to the fourth over 6 times x y to the fourth c squared. And well, we got to proceed to simplify this stuff. So simplify. Here we got third and third. So the third 2, third 9. So it will be 6 1 6 3. Now let's just write it down. So it will be 9 halves. The first guy, the first simplification will be times. We simplify the x. Will be 2 minus 1. That will make, of course, a 1th power, which we will not write because it's just common, not writing the 1. So here will be y raised to the 5 minus 4. We subtract the exponents, and same case would be y to the 1th power. It would be c raised to the 1 minus 2. This will simplify to the negative 1. We will have to rewrite this expression. I'm going to do it in another step. We go minus, that will be 3. We subtract the exponents. We get x raised to the 2 minus 1. That will make, of course, a 1th power. And here comes a thing we can simplify as well. Cancel out the y's because they are raised to the same power. So it's pretty much like having a over a or a 5 over 5 for these y's. Y to the 4th over y to the 4th will be something equivalent to this, which we know this is equal to 1. So I'm going to write the y anymore, because it would be like saying, okay, y to the 4th minus 4, that's just would be y to the 0, which is again equal to 1. So okay, derivative will be times z raised to the 4th minus 2, and that will make, of course, a c squared. And after that, we are pretty much done. We just got to rewrite the first expression because we got this negative exponent. So we got 9 times xy over 2 times z. This is very confusing. See, it may look like a 2. There it is better. So it will be minus 3 times x c squared. And when this will be done with this example, and that will be it for this dividing polynomials with monomials. It's pretty simple. We're just going to start from, we just keep in mind that we are doing something pretty much to force a division, which is a polynomial over a monomial. We're going to transform it in cases such as the first one. And then we apply the same procedures we've been doing all along.